Myself, Srinivasan, working as a faculty in the Department of Mechanical Engineering at Sri Sharma College of Engineering and Technology. I'm going to teach a subject on deep learning. Before deep learning, you should understand what is machine learning. Okay. So, machine learning is basically a subfield of artificial intelligence, where we focus on learning algorithms. The learning algorithm will try to find some patterns in the data. So, once you find some pattern in the data, it will generate some model, and that model can easily predict for the case of new data or unseen data. Okay, so that is the way the machine learning works. So if you look at traditional programming and machine learning, the traditional programming has some logic. They write some code in that system machine, and whether you get some output of it. But whereas in the case of machine learning, we put our features and we label them as far as supervised learning is concerned, and the machine will try to find some pattern out of it that will generate some model. Okay, so that is the way the machine learning works. Okay, so there is an analogy between machine and human. Okay, for a machine now, based on age and based on experience and based on the past experience, and we are able to make some decisions. How it happens? Because based on experience, we'll get some knowledge and skill, and that helps us to take some decision for the new scenario. In case of machine learning, we have the database, and that has both input and output, and that when you apply a learning algorithm, you try to find some pattern in the data, and finally we can generate some model. So based on whenever we give you new or unseen data, it can able to predict. So based on that, we can take some decisions. So the analogy here is basically in the human, we get some skill, and based on the experience or skill or knowledge, okay, and here we get some model. So that is the analogy between the human and machine. Okay. So we have been talking about model. What is model? Model could be anything related to this. Okay, so that this could be a mathematical equations, so that we have come across integration form, and that model could be the form of tree or graphs. So this comes under nonlinear data structures. And whenever we apply some sort of rules, and if we apply some logical rules, and that also comes under the category of models. When we see some data are similar, that when we ungroup them in one category, then this can be used for the clustering type. Okay, so whatever we discussed so far all comes under the category of model. Okay. In today's world, machine learning is widely used in the healthcare industry, and natural language processing, and for the business purpose, autonomous vehicles, and agriculture and social media. So if you look at this autonomous vehicle, and we have a sensor in the car ADAS, and we have sensors in the car. It based on that, it detects and captures the images, or it is getting analyzed by some algorithms. It has some computing devices, and based on that, it is helping us to take some decisions. For example, when you want to apply brake, or when you want to accelerate, and those decisions are based on this machine learning algorithms. So if you apply this machine learning in autonomous vehicle, it helps to reduce the accident. It helps for driverless vehicles. Okay, and that is a major use in around the world. Okay, so if you look at the agriculture land, and if you have many acres of land, if you find if there is a disease in the plant, and we can use the drone technology to apply the fertilizers. So that can be widely used. Okay, so that when you have sensors, and when it will capture the images, or when you have camera, it capture the images based on the disease is analyzed, and which portion is affected. Based on that, we can apply the fertilizers. So that reduces the amount of fertilizer added to the soil or to the uh, area. Okay, so that is the advantage of using ML in agriculture field. Okay, so when you have this social media, it tries to find content, and whether it is fake or the real one. Okay, so it helps us to help us, it doesn't mislead the people. Okay, so that's where the machine learning is used in social media. So in business, if you look at business, and based on the past history, we can able to predict and what is going to happen in the future. So based on that, in business and all over the bill throughout the year, we will not have the similar revenue, and it varies from the season to season. So based on this past data, one can say what is going to happen in future. So that helps us to take decisions. Okay, so when you look at this natural language processing, and it can convert the language translation and speech recognitions and sentiment analysis, summarization. There are many ways this machine learning is used in NLP. Okay. So now we have in India itself, we have around 150 crores of people, and we don't have much of doctors. And if you work on this aspect, and we can able to take some decision based on the data that we have. Okay, so it is widely used in widely used that drug discovery, and it is widely used in medical image processing, like if you have MRI and X-rays and all, and it helps out to predict. I mean, we suggest, and it helps us to take some decisions when you suggest something. Okay, so not only that, it helps us to monitor the health. Okay, so there are many ways the machine learning is used in healthcare industries. When we go for building the machine learning model, this is the general framework that we use for the uh, predicting. Okay, for the prediction. So usually we will have some data sets, and that data sets is going to be used. That data sets has to be pre-processed. For example, you will have many features in the data. Then sometimes you will have uh, reluctant features will be there. So you have to remove those things, and the PCS is usually basically used for reducing the dimensionality, and the SOM, the self-organized maps, is used for some identify some patterns. Okay, so if you have some missing values in the data, that can be corrected in the pre-processing step itself. So once you have these pre-processing steps, you will have this input features, and this is going to be my output sample. Okay, so once we have these two categories, and what we have to do is we have to split into two types. One is training data set, and another one is test data set. Okay, one is the training data sets will be used. A majority of data set will be used for training purpose. Okay, so we based on the category of the data, and suppose if you have a category data, you have to encode it, and if you have a numerical data, you don't need to do that. And based on the pattern that we see in the data, we can use some different algorithms. We have the linear algorithms and non-linear algorithms. So there are many things out there, and each algorithm will have some advantage and disadvantages. For the case in suppose, like, for example, if you have a non-linear algorithms, non-linear data structures, and it is very complex, one can use a neural network. So here there are many linear learning algorithms support automation, and random forest, decision tree, k-nearest events, and deep learning algorithms. All there are many neural network to be used for the case of capturing the or developing the models. Okay. So while using the learning algorithm, we'll have some hyperparameters. Okay, then we have to see we have to update the hyperparameters. So if you look at the training data set, one certain portion of the one portion will be used for the cross validations. Okay, to fine tune the uh, hyperparameters. Okay, so once you do this, you will get you will have a trained model. Okay, so once you have the trained model, and we can apply this to a new or unseen data. Okay, that comes over here. Okay, so once we have this test data set, and we'll be able to predict something. Okay, So based on the prediction, you can compare the real one. Okay, so you can calculate the loss function. There is error you can calculate, and based on that, we can go for the how well it is predicted. Okay, how much it is accurately predicted. So this is a model performance can be done in two ways. As far as classification is concerned, we work on accuracy, sensitivity, specificity, and all. And when we go for this regression and R square, mean square error, and root mean square. So these are the metrics that we use for the case of classification and regressions. So this is a general framework that we follow for machine learning.